A very warm welcome to all of you. Myself Rajan Choudhary, Professor in the Department of Civil Engineering, IIT Guwahati, instructor for the NPTEL MOOC course Pavement Construction and Technology, funded by Ministry of Education, Government of India. Our today's talk will be an extension of the talk under lecture 30 of module 12, where we discussed about specifically the full depth reclamation along with the discussion on the cold in place recycling and cold in plant recycling. So today this is a discussion in extension to this particular one, where we will discuss some of the key aspects related to the design of cold recycled asphalt mixes. Now, at the very beginning, I would like to acknowledge the use of text, informations, graphs and images sourced from various textbooks, codal standards, journal articles, reports, newsletters and public domain searches. So now coming to the design of cold recycled mixes, specifically there are certain key features which are there which makes them different from the design of your hot recycled mixes. And what are those key features? One important key feature is moisture adjustment. As in case of hot mixes or hot recycled mixes, we don't want to have moisture content specifically as low as in case of RAP. But in the case of cold recycled mixes, there is a requirement of a particular amount of moisture content, and that's why water is added to the reclaimed asphalt pavement, and added aggregates, virgin aggregates may also be there if necessary to achieve a desired gradation, to achieve the optimum moisture content which gives you the desired amount of workability to get a density. So here in the case of reclaimed asphalt material, you need to do the determination of your optimum moisture content and maximum dry density to get the required amount of water which is to be there. So some amount of water may be already there in the RAP and some additional amount of water may be required to. Usually this water content goes in the range of around 2 to 6% around in this particular range, which gives you a maximum density with the reclaimed asphalt pavement. Then in addition to this one, specifically in cold recycled mixes, you prefer to use additives like cement and hydrated lime, because they are there, you produce these stabilized base courses, and to enhance the strength of these and the durability of these two additives are, we call them as active fillers, because they produce compounds which adds to the stability. They react with the water and helps in better dispersion of your bitumen emulsion also, and imparts a greater strength and durability to your cold recycled asphalt mixes also. The third important thing is, here the main focus is usually on the density. Instead of air void content, we will prefer to go for the more focus is specifically in case of density. We also go for measurement of the stability also, the indirect tensile strength also, the measurement of your tensile strength ratio also. So wet, the dry unconditioned samples and the conditioned samples, the strength of unconditioned and conditioned samples are compared as we did in case of the hot mixes also. But here you will find more concentration will be given specifically on the density, because we are producing it as a stabilized base course. So more focus will be on density compared to the air void content, because air void content may show a high variability with the change in the specifically your reclaimed materials, because you are involving a greater depth of layers in it. Curing, this is another aspect which is usually not required in case of hot mix asphalt. After say an overnight, the surface can be opened for the traffic, but here curing is an important aspect in case of design of cold asphalt recycled mixes. The material is allowed to cure before placing the wearing course, either after reduction in moisture content or as specified. So either you go for, as mentioned in the earlier talk, in case of say formed bitumen stabilized base courses, you will see how much the water content has gone down. So that the surface has reached to that particular level of dryness, then only the wearing course can be applied over it. Or it has gone for a given period of curing, I say a period of curing which may be 3 days or 7 days, after which you are going to go for the application of wearing course. So these are some main differences which are there in design of cold asphalt recycled mixes compared to what you have in case of hot mix asphalt. Now let us look what are the important steps which are involved in the design of cold recycled asphalt mixes. One is the gradation of the wrap. Here another important aspect is we are not going to consider the binder which is available with the reclaimed asphalt pavement. They are treated as black rock. So it's treated as a black aggregate particle. The binder which is present over it will not be taken into consideration. This is one important difference which is there. So you are going to go for the gradation of the wrap as it is specifically. So the cold recycled asphalt mixes design utilizes the black rock gradation of wrap, treated wrap particles as aggregate rather than using extracted aggregate gradation. So this is another difference which is there specifically what you were having in case of hot mix recycled mixes also. So wrap samples for gradation analysis can be prepared, and from where do you get? You can get it from your milling operations. So small milling jobs can be taken up from the existing pavements. They may differ from that of a full size recycler, because in actual there may be a big size recycler which may be used. So initially for some samples you have used a small milling machine, so a bit difference may be there in the samples of or the gradation of the wrap, or it can be seen by extracting the pavement cores from the project site and then crushing it using jaw crushers at laboratory scale to achieve the desired maximum particle size. As I mentioned, maybe typically around say, because considering the laboratory mix design, the maximum sizes are typically restricted to around 40 mm in that case. If the wrap gradation falls outside the recommended virgin recommended range, in that case if it falls out of the recommended range, virgin aggregates must be added to adjust the overall gradation. This is the another important requirement. This virgin aggregate is typically spread. Now how this particular one is specifically added in case of cold in place recycling or in case of full depth reclamation, this whatever the additional virgin aggregates or your stabilizing additives which are required are spread on the existing pavement surface in front of your recycler. So this is another important consideration which is to be there. Determination. Now in laboratory definitely you will be using your Pavement mixers where you can incorporate it directly, but simultaneously how it is done on the field, that is mentioned. So determination of optimum water content for mixing. So the optimum moisture content of wrap similar to that of soils and aggregates, as we discussed earlier in our earlier talks when we determined the optimum moisture content and maximum dry density of granular materials as well as for subgrade soil. So using the IS 2720 specifically part 8 which is there for heavy compaction. So and this can be attempted both if we are using wrap alone, or if a combination of wrap and virgin aggregates are there, then both have to be combined together in the desired proportion, and then this moisture content is to be worked out which gives you the maximum density. So the moisture content corresponding to the maximum dry density is selected as optimum, as it ensures effective compaction and uniform distribution of the recycling agents. So this is what is, because if you have this much of, then whatever your recycling agent is there, it gets a better distributed and you get a good density also. Then another feature which is to be taken care specifically is the use of some active fillers. Active fillers specifically your lime and your cement are the two most commonly used active fillers. Bitumen stabilization is typically carried out with a small percentages of active fillers. The percentages of hydrated lime may be around 1.5% and the cement may be around 1%. To enhance the dispersion of the bitumen within the mix, this is an additional advantage which is there, and along with it gives you higher soaked strengths and durability values when these active fillers are used, because they adds to the strength and durability of your mix. So we need to look for the incorporation of active fillers along with this particular water content part. Then As I mentioned, the typical percentages which are there are used, it is depending upon the RAP gradation, it may vary. The typical contents are of hydrated lime is 1.5% and of cement. If we go for higher contents of cements, usually it makes your mix more harsh, or you can say it makes your mix more brittle. So you normally don't prefer to go for higher percentages. These are the typical percentages of cement which are used for these cold asphalt recycled mixes. And what are the key advantages? Some of them already discussed. Enhances foam bubble distribution in foamed bitumen mixes. This is one advantage. It distributes, it leads to a uniform or a better distribution of foamed bitumen in cold asphalt recycled mixes. Improves wet as well as the dry strength. So whether you measure by any test, specifically in terms of Marshall stability, retained Marshall stability, or indirect tensile strength, both conditioned and unconditioned, it helps us to improve the strength of these cold recycled mixes. And more this is quite useful if these ones are showing marginal performance without these additives. Promotes early strength gain, because as we have seen, the curing periods may be ranging from say 3 days to 7 days. So in that case, early gain in strength is required to reduce the in that particular case, so that it can be allowed for the traffic. So these are again active role fillers, or this hydrated lime and cement plays an important role. Contributes to long-term strength and durability of the stabilized. So that's why these are quite popular specifically in the design of cold asphalt recycled mixes. Recycling agents, two recycling agents are used. One is your bitumen emulsion, emulsified bitumen, and second is your foamed bitumen. In cold recycled asphalt mixes, a recycling agent which is a binder is used to bind the reclaimed materials. The two commonly used are your foamed bitumen and emulsified bitumen. So just we need to look about the key characteristics of the foamed bitumen, specifically the one which is very popular in producing these cold stabilized base courses. So two important parameters which needs to be ensured when you are using the foamed bitumen to produce these stabilized courses. One is the expansion ratio. As I mentioned, the foaming of the bitumen is done by adding of water to hot bitumen. Hot bitumen means the temperature of the bitumen is in the range of around 160 to 200 degrees centigrade, and we usually add a water which may be ranging from 2% to 6% of mass of your bitumen. So that particular one is injected. It leads to the foaming of the bitumen, and the expansion in volume may be 8 times, 10 times. Your desired range is around 8 to 10 times the volume expansion should take place. So expansion ratio, what is the expansion ratio of a foamed bitumen? The ratio of the maximum volume of the foamed bitumen with respect to the volume of original volume of hot bitumen. So it reflects the degree of expansion. More the degree of expansion, lower the viscosity and easy to coat your aggregates or your reclaimed materials. Half-life, this is another important aspect, which is that because once this is there, the expansion is there, after this particular one, in due course of time, the volume will start reducing. So it says the time it takes for the foam to collapse to half its of maximum volume, specifically that is given in seconds, is again an indication of the stability of the foamed bitumen. So this particular one is basically, usually we recommend to have a value of around 8 to 10 seconds, that at least 8 to 10 seconds should be there by the time it collapses and comes down to half its volume. So since this foaming is done at site itself, so usually we need to check for different percentages of water with respect to the two parameters. One is expansion ratio and second is the half-life. So you can see, as we can see, the expansion, this is the expansion ratio, black line is the expansion ratio. So more is the water injected. We can vary it, say from the percentage varying from 2 to 5% or 2 to 6%. As the water injection is more, the expansion is more. Here it can say is the expansion ratio, which is the volume of the foamed bitumen with respect to the volume of the original bitumen. So our target may be say around 8 or 10. So here I am showing a target of around 10% expansion in the volume is there. Simultaneously, this half life, this goes down as the water injection or the water injection of percentages of water is increasing. So this white one shows the half life, and what my target for half life is around 10 seconds. If I am keeping my target for half life is 10 seconds, so I get the 2 water injection percentages, and I can pick up a middle one of this particular one, which I can select. This is the combination of at site. I'll require to have around 3% of water injection to get my desired foamed bitumen. So these parameters are essential for evaluating the quality, workability and effectiveness of foamed bitumen in the recycling process. So these are 2 important parameters specifically taken care during the lab produced stabilized courses also, and plant and in situ also. Both these parameters specifically what we have, the expansion ratio and the half life, they depends upon the amount of water, the bitumen type, specifically the grade of bitumen which is used, the source of the bitumen, the temperature. So the temperatures may be in the range of 160 to 200 degrees centigrade. So you can work it out this particular one at different temperatures also to get a suitable water injection percentages, water pressure and additives. So these are some of the parameters over which this expansion ratio and half life depends. Now, when we are using an emulsified bitumen specifically as a recycling agent, the most commonly used is a cationic slow setting emulsions are there. And even in this case, many a times it has been observed, if the wrap is already having some softer grade of binder coated over it, then we can prefer to use a cationic slow setting emulsion which has a base binder which is of a harder grade. So you can prefer to use cationic slow setting one, which is with say 1H, where H represents the harder base binder. So this can be used specifically if you are finding that the whatever the binder which is there on the wrap is a softer one, then emulsified bitumen having a stiffer base binder can be used, and the most preferred grade is cationic slow setting emulsions which are used. And the other thing is, whenever we are using these active fillers specifically with the emulsified bitumen, we need to ensure that it does not causes the emulsified bitumen to break too quickly, otherwise it will be difficult to produce the mix and it will be more difficult to compact that particular mix. So that is why these foamed bitumen is more popular specifically in the production of stabilized base courses, that means in your code in place recycling or the full depth reclamation, because the foaming is done on site. This is one additional advantages. Foamed bitumen treated material can be usually placed, compacted and opened to traffic much earlier or comparatively earlier compared to what we have with the emulsified bitumen treated cold mixes. The treated material remains workable for a longer period of time, so you can stockpile it for some later use. So these are some specific reasons why this foamed bitumen is more popular in the production of these cold asphalt recycled mixes. Now, while doing the laboratory mix design, you need to work out the optimum binder content, for which the samples has to be prepared, the specimens has to be prepared, and we use a mechanical bucket mixer or a laboratory size pug mill mixture can be used with the pedals which are there. So, and whatever the required amount of active fillers, different percentages can be tried, along with if virgin aggregate is required, that is to be added and mixed in the pug mill to get a uniform blend, and usually around 30 seconds are required to get in laboratory to get a uniform blend of it. Then the water is again added, and for this particular one you need to ensure what is the existing water content in the wrap. So then whatever the additional water content is to be added to reach to the optimum moisture content, again it is to be mixed. Finally, on the after that particular one, the recycling agent, which is either emulsified bitumen or foamed bitumen, that is added to it into the mix, ensuring that the cold recycled asphalt mixes is uniformly coated at room temperature. So there is no heating which is involved here. So then whatever the required doses of your emulsified bitumen or your foamed bitumen are added. Now this particular one, for to work out the optimum dosage, we usually try at least 3 to 4 contents of your foamed bitumen or your emulsified bitumen. And like for an example, typically you have the optimum binder content is in the range of 2 to 2.5%, but maybe as low as 1.8% for a mix with foamed bitumen cold recycled asphalt mixes. So, different with the different combinations of virgin aggregates RAP, we need to at least work out 3 to 4 different trial binder contents for preparation of these specimens to get your optimum binder content. Now, when we are doing the second steps, once at these different trial binder contents, at least 3 should be, minimum 3 should be there, then these cold asphalt recycled mixes are to be compacted. As we go with the Marshall method of mixed design, so they can be compacted by giving 75 number of blows on the both side. If gyratory compactor is available, 30 number of gyrations are usually used for for compacting these specimens. Now, thereafter comes the curing. The curing, which is typically, these are some of the usual conditions which are mentioned, which may differ specification or differ from region to region. So, these are some of the most commonly preferred combinations are there. So, for foamed bitumen as a recycling agent, compacted specimens are typically cured at 40 degree centigrade in a forced draft oven for 72 hours till in this particular one. So, first it is done a curing at 40 degree centigrade for 72 hours and then cool to room temperatures at 25 degree centigrade for 24 hours. So, this is how this particular curing is done specifically for foamed stabilized mixes, and then these can be tested for the indirect tensile strength and can be. So, for indirect tensile strength, as the test is to be done at 25 degree centigrade, so we keep these specimens at for 2 hours at 25 degree centigrade and then we go for the indirect tensile strength. Similarly, we can go for the this is unconditioned, or I can say the dry ITS value. Many a times many specifications requires to put up a requirement of your tensile strength ratio, which is your ITS, which is your wet, upon ITS, which is your dry. And it says that many specifications says that this value should be at least 70% or 70 to 80%, depending upon the different codal guidelines. This range may be 70 to 80%. So, tensile strength ratio for most of the cold asphalt recycled mixes, as per our IRC 120/2015, it says usually tensile strength ratio of 70% is preferred, is considered for evaluating these mixes. So, we can have the dry ITS value and the one after conditioning it at 25 degree centigrade in water bath for 24 hours, and then we determine the wet or the soaked ITS value, and thereafter we get the tensile strength ratio. When it is there for the emulsified bitumen specifically, then the specimens are first cured to a constant mass at 60 degree centigrade in the forced oven draft. So, this is to be ensured. It is to be first cured in a forced draft oven at 60 degree centigrade. These are some of the typical conditions which are recommended, and after curing the specimens are cooled at 25 degree centigrade, again brought down to ambient temperatures of 25 degree centigrade, and then the strength of these specimens can be either measured in terms of Marshall stability or ITS testing. Usually for Marshall stability, the testing is done at 40 degree centigrade, and for ITS the testing is done at 25 degree centigrade. Now, for this particular one, even many a times for cold asphalt recycled mixes, they go for retained Marshall stability. So, then conditioning, one will be dry Marshall stability value, which will be determined at 40 degree centigrade. Second will be the stability, which will be determined after it is subjected to soaking condition. In soaking condition also, it is many a times referred that you go for a saturation of these samples to a particular degree, and thereafter the stability is measured. Whereas, when the ITS value is to be measured, then the sample has to be kept submerged in water for 24 hours at 25 degrees centigrade, and then you measure the ITS, which is your wet ITS or the soaked ITS, and then you determine. So, usually the ITS values which are recommended by different specifications, they say that the dry ITS values may be ranging from 200 to 350 kilopascals. So, these are some typical requirements. It depends upon specifications to specifications. The dry ITS values may be in the range of 200 to 300 kilopascals, and your wet ITS values may be around 100 to 150 kilopascals. And then as I mentioned, the tensile strength ratio, as per IRC 120, it recommends for a value of 0.7. That is 70% of the indirect tensile strength should be retained after subjecting that sample to the soaking conditions. So, then we need to work it out, what are the ranges where you are able to achieve these desired for different binder contents where the trials have been done. We need to work out what are the binder contents where you are able to achieve the requirements in terms of your ITS. Mainly it is done in terms of ITS and TSR, and for pavement design part, the resilient modulus can be also determined, as well as it can be estimated using the values of ITS, and then the resilient modulus values are used in the design of flexible pavements using IRC 37 2018. So, these are the two main indirect tensile strength and the Marshall stability, which are usually measured on the design of cold recycled mixes. So, and where you get your minimum values for stability usually we have around we go for around 5.5 kilonewton is required, as we have for most of the dense graded mixes where it is around 9 to 10 kilonewton. Here the strength achieved is around 5.5 kilonewton is there. The requirements by many specifications, it says for a value of around 5.5 kilonewton. So, depending upon the requirement of the specification of the project, the region is specific, the optimum binder content which meets, or the binder content which meets the requirement of TSR, ITS, Marshall stability. From those 3 to 4 different trial binder contents have to be chosen up, and that forms your optimum binder content. So, this is a brief discussion specifically on the different aspects related to the design of cold recycled mixes. So, for formed bitumen, the dry and wet ITS are plotted. This is usual, as we did do in case of hot mix asphalt design. We can plot the ITS values, dry, wet ITS values with respect to the binder content. So, select a binder content which meets the minimum requirement of ITS and TSR. Similarly, for emulsified bitumen, as I mentioned, we can have the requirements for the dry stability as well as the wet stability, which is arrived after subjecting the samples to the saturation. To determine optimum asphalt that meets the required criteria for dry stability and retain stability, if the ITS is used, the emulsion content that satisfy the minimum criteria for ITS and TSR is selected as an optimum. So, it depends upon the specification. What it says if it says in terms of ITS and TSR, or whether it says in terms of Marshall stability and retain Marshall stability. On the basis of that, you will pick up the optimum binder content. This completes our discussion specifically with the design of cold recycled mixes. And finally, whenever these different recycling techniques which we have discussed, especially one under the category of hot mix asphalt recycled mixes and second under the category of cold asphalt recycled mixes, whichever technique has to be picked up, these techniques usually offer a good amount of advantages or in compared to going with only the conventional methods without using reclaiming the distress payments. But the choice of a specific method should be carefully decided. This is very, very important on the type and cause of the distress, because as we have seen in full depth of reclamation, if the problem is existing with your base courses, unbound courses, which forms a big thickness of your pavement, if the problem is resting in those courses, and if you go with some say small treatments or techniques of recycling, say where you are going for hot in place recycling, making only recycling the surface courses, it may not serve your purpose. It may not be able to address this particular concern and the distress may reoccur. So, specifically in these recycling techniques, it is very important to choose the correct technique which is to be used for specifically any particular type of distress. For that we need to know the causes of the distress and which particular layer is contributing to that distress, as not all methods are equally effective for every. If the problem is there with your surface courses only, wearing courses only, and if you are attempting a full depth reclamation, again it is a waste of money. So, one has to be very cautious while picking up the recycling technique depending upon what type of distress and what type of stabilization or strengthening is required. So, this is all about this particular one. Thank you so much.